Okay, so the next question was the decryption question. Find the inverse of this matrix 5314 and use it to decrypt this ciphertext JTSRBY. Work on mod 26 with numerical values, or the alphabet A to Z have a numerical values 0 to 25. Okay, so I've written up the question here, so we're I'm just trying to see, is my board cracking already? To be only been up one day. It's feeling the worst for already. Anyway, okay, so I'm going to call this matrix A just for the crack. It's the easiest way to give it a letter. So the first thing I need is det A, determinant of A. So determinant of A is going to be equal to 5 times 4 minus 1 times 3, which is 17. Okay, and the important thing then is I need the inverse of A mod 26. So I need det A inverse mod, we're working mod 26. Okay, so we need to make sure the 17 has an inverse mod 26. Okay, so 17 inverse, I need the GCD of 26 and 17. Okay, so 26 equals 1 times 17 plus 9, and 17 equals 1 9 plus 8, and 9 equals 1 8 plus 1. Okay, so the GCD is 1. That'll be the last non-zero remainder. So I do that in reverse then. 1 equals 1 9 minus 1 8. Replace the 8, which is 17 minus 9. So 1 9 minus 1 times 17 minus 1 9. So that's going to be 1 9, 2 9s minus 1 17. And finally replace the 9. So it's going to be equal to 2 times 26 minus 117 minus the other 17. So that's going to be equal to 2 26s. 2 26s minus 2, 3, minus 3 17s. Okay, 52 minus 51 is still 1. Okay, so the inverse, 17 inverse is minus 3. And we're working mod 26, so I'll actually add on 1 multiple 26 to get a positive number, so the answer is 23. Okay, so now what I have is A inverse, the multiplicative inverse, or the multiplicative inverse of A, the modular inverse, I should say, of A mod 26 is going to be equal to 23 times, it's not 1 over the determinant, it's determinant inverse. So 23 is the inverse of the determinant by, we have to switch this matrix, switch the 5 and the 4, so 4 and 5, and put negative signs in front of the 3 and the 1. Okay, so that's going to give me 92, I'm thinking, minus 23, minus 69, and 115. And remember, I'm working mod 26, so that's going to give me, I want to make sure that thing 26 goes into 78, so that would be 14. Sorry, the phone's hopping all day with all these messages going all day. So 92, I'll just subtract 78 just to make sure. Yeah, 14 as suspected. Minus 23, I just add 26 on, so that gives me 3. Minus 69, I want to be positive, so I'll add on 78. 78 is a multiple of 26, by the way, that's where I'm getting that from. 9 and 115, I think 26 goes into 104, so I'll just take that away. 104 is just going to give me 9 as well, isn't it? Or is it going to give me 11, sorry. 115 minus 104. I'll do this with my head and make mistakes. So that's our A inverse, so there will be a heap of marks for getting that bit right. Okay, so the next thing is we need to multiply this by our ciphertext. Okay, that's our decryption matrix. So we've got to take our ciphertext. Okay, so we need to put in JT. So J is 9 and T is 19. SR is 18 and 17. And BY is 1 and 24. Now, I believe Blonde was doing these in the tutorial, which is by just doing like 2 at a time. You can obviously do the 9 and 19 in one go, and then the 18 and 17 in one go, and 1 and the 4 and so on. Do it that way. Or you could just do, matrix multiplication the whole way. 1, 14, 9, 3 and 11. So make sure I copy that down right. So I got to multiply this out the usual matrix multiplication way: 14 by 9 plus 3 by 19, then 14 by 18 plus 3 by 17, and 14 by 1. Now, unfortunately, I don't have a situation where here's one I did earlier because I didn't. So it's going to have to work it out the long way. So 14 by 9 plus 57 is 183. Now, as you know me, I'm going to do this, do it mod 26 at the same time. So I'm going to divide that by 26, which is 7, subtract the 7, and multiply by 26. So you get a whole number, and it's 1. Okay, so the next one across is 14 by 18 plus 51, which is 303. Divide that by 26, slash minus the 11 equals, and multiply 17. Then I've got 14 by 1 plus 3 by 24 is 86. So that should be 8 when I do mod, and 26 goes into 78, so there'll be 8 over. Then I do the bottom row, so 9 by 9 plus 11 by 19. So 11 by 19 plus 81 is going to be 290. Divide that by 26 is that. Multiply by 26 is 4. 9 by 18 plus 11 by 17. 9 by 18 plus 11 times 17 is 349. Divide that by 26. You get 13 point something, so I'm subtracting the 13 bit and multiplying the rest by the 26 to get 11. And finally, 9 by 1 plus 11 by 24. 11 times 24 plus 9 is 273. And, well, 260 it goes in, so that's 13. So let's see what this gets. 1 is B. E. 17 is or. 11 is L. 8 is I. And 13 I'm hoping is N. The matrix, so it's equal to Berlin. And that's that question. Cheers.